Kenosha, Wisconsin, known far and wide as the Better City, home of industrial facilities which turn out products marketed in just about every country in the world. A city with an outstanding pattern for progress. The huge American Motors Corporation, with one of the most and complete plants in the automotive industry, covers more than 110 acres on the west side. The nerve center that sparks this vast network into action is the teletype department, an operation that bustles with the same spirit of urgency found in newspaper city rooms. Rambler orders and specifications are communicated to all stations to alert each to its particular responsibilities. A finished unit is no better than the raw materials which go into it. American Motors technicians check and double-check the quality of materials involved in the manufacture of the famous Rambler automobiles. 1,000 magnification is used to examine the structure of a hardened steel part. The fluidity of oil for the first engine fill is carefully checked. The amount of sulfur in a melt of cast iron for engine blocks is a vital consideration. The hardening power of a new lot of steel bars must be accurately determined. Attention to details has been a prime factor in Rambler manufacturing since Thomas Jeffrey first created his two-cylinder horseless carriage in Kenosha in 1902. That year alone, 1,500 cars were built by Kenosha craftsmen. Each gear, then as now, was meticulously produced. The Jeffrey record of mechanical soundness and contemporary styling has been maintained through the years to win public acclaim. Here, cylinder blocks are completely machined on the latest types of automatic transfer equipment costing millions of dollars. The blocks are inspected 100% dimensionally with particular stress on cylinder bore finish. All major components of the engine, such as this crankshaft, are individually balanced statically and dynamically prior to mass balancing of all components in the final engine assembly. The idea that the whole equals the sum of its parts is more than just a mathematical concept at American Motors. It's a working formula to assure the best completed units men and machines can produce. Crankshaft bearings are thoroughly inspected for size, the latest type air gauging equipment which records in 1/10,000th of an inch. All cylinder bores are measured with air gauges to determine the precise piston size required. The work is exacting, since the most minute error might reduce the efficiency of the entire engine. Two assembly lines put together the powerful units that provide go power. All engines are fully tested to simulate actual operating conditions in the vehicles. A teletype tag is affixed to each engine to assure that it includes the accessories to coincide with components ordered by the customer on the balance of the car. Now, these include power steering, power brakes, air conditioning, automatic transmission, many other refinements. Axle gears, pinions, and ring gears are precision machined. Pinion and ring gears are silent tested and matched as sets prior to axle assembly. And for display of sheer power, the draw presses rank as the super machines of the automotive industry. All major body sections are shaped in the heavy presses. The draw operation on a Rambler front fender brings up to 550 tons pressure to bear on the flat metal. Many visitors to American Motors are amazed at the amount of mechanization. The era of the strong back and weak mind in factory production is a condition of the distant past. Today, industrial personnel at every level must be constantly alert to succeed in their duties, while machines take care of most of the muscle work. A factory worker in 1900, with only 1.8 mechanical horsepower systems at his disposal, earned an average of 20 cents an hour in a 10-hour day. Today, the average factory employee, with about 8.5 mechanical horsepower help, earns over $2 an hour. As industry prospers, so do the men and women who help it grow. Hoists of all sizes are among the labor-saving devices. Among their functions are the transporting of the 5 main subassemblies which make up the complete body. The subassemblies are the underbody, the body dash structure, 2 side units known as unisides, and the roof. The unisides include the door framing and rear quarter panels, while the roof contains the cowl and framing for windshield and rear windows. Some 8,000 spot welds unite the parts. All bodies are treated with a phosphate coating to prevent rusting and corrosion. During the unique dip process, an American Motors innovation developed during the 3 years of research, the entire body is submerged in a bath of primer paint. This virtually eliminates body rust in areas inaccessible to spray coating. After final painting, the windshield, and other trim is installed. Completed bodies, including those assembled at the American Motors body plant in Milwaukee, are transferred to the final assembly department for conversion into finished Ramblers. All along the line, the teletype communication has paved the way for quick and accurate assembly. Tires are automatically mounted and inflated to wheels. And finally, at the intersection of the assembly lines, the principal units come together to be joined into the stylish, economical car that will take to the highways and the byways. The engine, body, torque tube, axle, and other components merge to form the vehicle that graces showrooms all over the country. There are still minor adjustments to be made, but the process of being born is just about completed. Assistant Works Manager Walter DeVias checks the solid feel of a Rambler door as he and Works Manager Joseph Miller inspect a car just coming off the assembly line. More than 5,000 machines, 20 miles of conveyors, the most modern equipment, and awesome amounts of craftsmanship, engineering, and planning contribute to the finished product. Put them all together and they spell quality, a Rambler tradition of long duration. Factory Superintendent D.R. Hutchison and Assembly Division Chief Leon Hartle study a development test of front suspension structure. Tape recordings are made of noise transmitted into the car. Strain gauges measure the load on suspension arms and steering linkage parts. And long before the newest Rambler is seen on the public thoroughfares of America, the product has been subjected to torturous tests at the American Motors Proving Ground at Burlington, Wisconsin, 25 miles west of Kenosha. A few hundred miles of driving on rippled roads, fitted with chuck holes and cobblestones, bring out weaknesses that wouldn't show up under 50,000 miles of normal use. Another form of accelerated endurance testing is the inner track, consisting of gravel secondary road surfaces with an assortment of grades measuring up to 30%. In addition to general durability testing, this section is used extensively for checking transmissions and rear axles. The main track is used basically for brake testing and to determine the level of general performance. The modern Rambler has come a long way in size, shape, and performance since the days of the first Rambler displayed at the Columbian Exposition in 1893. That first vehicle was simply a two-wheeler bicycle. No, this isn't part of the original two-wheeler. It's used for accurate speed measurement. Under the leadership of George Romney, American Motors Corporation has emerged as a vastly strengthened industrial force. It is his purpose that the company shall deliver fully on its slogan, American Motors means more for Americans. The most famous little man in Kenosha is the Jockey Boy, symbol of a product sold in 99 countries across the world. Cooper's Incorporated, a name synonymous with the very best in knit underwear. The company continues to grow under the leadership of men like Vice Presidents Herman Fredrickson, J.H. Weiss, and President Robert F. Cooper. He's a grandson of Samuel T. Cooper, who founded the firm with his 3 sons and 6 knitting machines in 1876. The batteries of machines in use today are the best examples of modern knitting machinery and require a great deal of skill to operate properly. Here, cotton yarns are knit in tubular cloth, the very first step in the manufacture of jockey underwear. After the cloth is knit from unbleached cotton, it is a light tan in color. The fabric is rotated through a special bleaching compound to produce the whitest cloth without damaging the material. After bleaching, the cloth is rolled up, sized according to width, and fed into a giant dryer. It's dried by hot air as it forms huge loops inside the machine. Steaming apparatus smooths out the cloth and sets the width. Once again, the material is folded in precise widths. The cutting tables are next along the line of march. As the layup man spreads the cloth, he inspects constantly for flaws. Pattern pieces are laid on the top layer of cloth, then marked out. This provides the cutter with guides to follow, outlining each of the separate segments of cloth that will be combined in the finished garment. If the cutter happens to go astray even a fraction of an inch from the pattern outline for a particular piece, he automatically ruins the same piece in every layer on the table. The responsibilities of cutting and sewing take skill and experience, and Cooper's people have plenty of both. The lightning speed of the sewing machine operators comes after months of practice. No product in the history of the men's underwear industry has been merchandised so thoroughly and so continually as the famous Jockey line. Constant innovations are made. For example, Jockey became the first prepackaged underwear, and other manufacturers, recognizing the trend toward self-service, followed the leader. Experiments with automatic packaging machines proved one thing: there's nothing as quick and sure as the well-trained human hand. Shipments go out constantly to retail outlets from a vast stock of merchandise. Coopers must maintain a large stock so that stores can carry a normal supply, and yet be able to draw on Cooper's reserves quickly. Company engineers designed a box-making machine not only to speed up, but to cut the costs of packaging as well. After the boxes are made, they're tied in convenient, easy-to-handle bundles. For plant manager Ken Bruder, each working day is concerned with thousands of individual details that add up to the overall manufacturing process. In the advertising department, creative men like William Herman and Jerry Respecki help to maintain a complete merchandising service for customers. A countertop dispenser for Jockey underwear, point-of-purchase display materials, retail sales education, newspaper ad mats, and other promotion devices. Among the reasons that Jockey underwear is so well known all over the world is that 17 different firms in foreign lands manufacture and distribute the line under license from Coopers. Each does extensive advertising. Here in this country, Jockey products are manufactured and distributed by separate plants and facilities in many areas, in addition to the original and expanded Kenosha headquarters. New firms are constantly joining the Cooper organization. Here, 2 members of a Buenos Aires firm signed contracts with Marketing Vice President J.H. Weiss. The company has much in which it takes a great deal of pride. As Cooper's was founded and remained a family company, so have its personnel remained as members of a happy family. Kenosha and Coopers, partners in a pattern for progress. Since 1943, Halbrick Brothers Manufacturing Company has been supplying Kenosha industry and manufacturing firms throughout the country with special equipment. Otto and Herbert Halbrick, with long experience in the machine tool field, have produced tools, dies, jigs, fixtures, and special machinery for major industrial enterprises, including Kenosha's American Motors, Simmons, Frost Company, Triclover, and Dynamatic. Their shop is renowned for high-quality products and reliable service. Back in 1912, Kenosha had everything desired by industry: water supply, adequate transportation, and an ample supply of factory and office help in a growing city of home-loving, home-owning people. That's when the McWhite Company settled in Kenosha. Today, President George Wilder and Vice Presidents F.D. Holden and E.C. Berg carry on the traditions of quality and durability which have made the firm's wire rope products among the most wanted by industry. Here they see rope of extra high strength give way against a pull of 58,000 pounds, exceeding standard by a large margin. The patenting operation is a first step in the preparation of steel rods for cold drawing into wire that will be fabricated into rope. The wire is pulled through gas-fired furnaces at 1,800 degrees. Next steps are a 980-degree salt quench to set the steel in its best structure for subsequent cold drawing, and the application of a special coating to help ease the wire through tungsten carbide dies. The dies are so hard that they require diamond dust and olive oil to polish them to perfect size. Nothing is scraped off in the wire drawing process. The strand becomes smaller, longer, and stronger as it is drawn through the precisely sized die. This is called cold drawing. The wire-making process requires experienced wire drawers who often spend their entire lifetime in this occupation. In addition to checking each coil for strength and uniform size, a torsion or twisting test determines the ductility of the wire. To make wire rope, the approved wires, as many as 325 in a single rope, must be carefully wound on bobbins. Inasmuch as wire rope is used for original equipment and replacement, it enjoys a steady demand. McWhite Company products are sold nationally and internationally through many distributors and warehouses. After assembling the wires into strands and winding them on bobbins, the units are placed in a closing machine. Here the strands are joined into the finished wire rope which will fill 1,000 needs in industry all over the country. Wire rope is used for vertical transportation on elevators, for machinery building our highways, for drilling oil and digging coal, for logging the wood out of forests, to name just a few. More than 1,000 wire ropes, each precision made for its own eventual role in industry, are the products of complete metallurgical control and engineering design, each in proper strength to meet the many demands. Special techniques in the drawing process assure high strength and safety in the finished wire rope. The high quality of McWhite products is the result of specialized experience. About 1 employee of every 5 has been with the firm more than 25 years. McWhite wire rope, truly a lifeline of industry. The story of the Arneson Foundry is the life story of Ole Arneson and his family. Since 1903, they have progressed from a single building to a foundry plant covering 15 acres. The day of hit-and-miss operation in the foundry is gone. Patterns for molding iron and steel castings must be extremely precise. The laboratory provides constant quality controls. All sand is analyzed for mechanical properties, and the metal itself controlled to fantastic tolerances. Cores are made from a mixture of sand and oil. All sand used in the foundry, whether for molds or cores, is highly heat resistant. The sand mixture is rammed into the core box, and then the box is reversed onto a supporting plate and withdrawn, leaving the finished core on the plate. The core is baked in an oven to produce a hard, rigid mass of sand, which will become part of the final mold. Cores are used to make intricate parts of molds when other methods are impractical. Silica sand, combined with certain clays and other bonds, is used in the preparation of molds. Finished molds are thoroughly dried by torches, since remaining moisture would generate steam when molten metal was poured into the mold. This would result in a porous casting. Iron is melted in the cupula, somewhat similar to a blast furnace. The heat produced by burning coke, intensified by forced air from a blower, causes the metal to melt. The molten metal trickles down through the layers of coke to form a bath at the bottom. When enough is melted, the fiery liquid is tapped by punching open a small hole, which allows the molten iron to run into the ladle for pouring. At this stage, the metal registers approximately 2,850 degrees Fahrenheit. Much of the change in casting practices was a result of World War II, when thousands of castings were made for the Army and Navy. Under the guidance of President Albert Arneson and other family executives, the rigid specifications and high degree of quality of castings originating with war needs has been maintained in daily operations ever since. On D-Day, as the barges reached the shores of Normandy, gears made by Arneson in Kenosha opened the doors to permit Allied troops to scurry ashore. Liberty ships, submarines, destroyers, and tanks in every theater of war contained castings from Kenosha. The Arneson Foundry is still making castings for our armed services, including installations on 2 of the largest aircraft carriers commissioned in the last few years. Vice President Russell Arneson and Treasurer Eugene Arneson, 2 more leaders in Kenosha's Pattern for Progress. From heavy machinery built to win wars to books published to educate and entertain children, Kenosha has them all. Look in the book collection of any child aged 3 to 10. Almost always you'll find editions published by Lowe Incorporated. Mrs. Edith Lowe, company president, seen discussing new artwork with editorial assistant Joseph Sackett, constantly strives to maintain a high level of quality and appeal in the firm's works. The business was founded in Kenosha in 1940 by the late Samuel Lowe, who severed connections with another large publishing firm to gain greater liberty for his ideas and methods of producing high-quality and low-cost books for children. Vice President William Cheek, Richard Anderson, Saget, and other staff members begin by laying out pages for maximum efficiency and economy. The largest and most modern 4-color offset presses are used. Large sheets consisting of many pages are printed at the same time. An automatic trimming machine cuts 3 sides of the books to size after they are collated and stitched. In yet another binding operation, a mammoth machine gathers and stitches sections and applies covers to bulky coloring books. Constant care and inspection of the binding operation is required to assure a good quality book. This is one of the responsibilities of Bindery President Jacob Resnick, in discussion here with Secretary Treasurer Julius Goldstein. Detailed planning for all stages of production is an absolute necessity when publishing books as superior as the Bonnie Childcraft series at a retail price of 29 cents. Production, binding, assembly, and shipping are the key operations performed at the Lowe plant in Kenosha. Ideal rail car loading and truck facilities contribute to mass production. The publishing of even a small book is a highly complicated task, requiring the creative efforts of many skilled people, whether they operate folding machines or write story material. Many conferences are held, and much preparatory work is done in order to produce an attractive, useful, and saleable book. One precision job is cutting printed sheets into various components. A single misstep would be costly. Even after books are bound, the operation is not complete. Many product items consist of more than the book alone. In the assembly department, girls put together the component parts. One activity kit consists of wipe-off picture cards, crayons, and crayon slates. Lowe Company books and kits are distributed through chain variety stores, retail stores, mail order houses, and wholesalers. Worldwide distribution is accomplished through exporting companies. In addition to its own publications, Lowe makes books for other publishers. This is recognition of the Kenosha firm's ability to produce the best at sensible costs. Ideas are culled and selected, artists are assigned, size, layout, binding are decided upon, rough dummies are made up. There are more conferences, the book is shown to the buyer. Finally, the go-ahead on production is given. Plates are made, paper purchased, the printing and binding are done. The famous Bonnie books, coloring books, doll cutouts, picture books, stories, novelty books, and other excellent books for children go forth from Kenosha daily to provide entertainment and education for children all over the world. The population of Kenosha was about 22,000 in 1912 when W.W. Vincent went into the manufacturing business. He was joined 6 years later by A.B. McCall, and the firm that carries the names of both these gentlemen was born. The Vincent McCall Company specializes in the manufacture of bedding equipment, and steel and aluminum furniture. During the war, the company produced large quantities of sleeping equipment for the armed forces. Vice President W.W. Vincent, Jr. inspects a fabric roll-away bed in knockdown form as it's prepared for shipment. Special devices such as mattress border measuring machines ensure a faster, more accurate job. The machine automatically measures the size border needed for either a full or twin mattress. At the same time, air vents are installed at precise points on the border. Hemming the mattress panels or covers and later attaching the border is one of the most difficult phases in mattress production. The Vincent McCall bedding and lawn furniture lines are distributed throughout the country with exports to Canada, Mexico, Central America, and the West Indies. The prosperity of Kenosha, the industrial city, is the sum total of the prosperity of its component companies. In our free economy, it is the customer who has the final say as to which firms will grow and which will decline. It is competition and not government regulation that permits each business to grow to the size which will serve the public most efficiently. As free competition continues, industry will produce more and better products at lower cost for everyone. Competition stimulates progress and regulates prices and production in a free economy. This is a basic formula in Kenosha's Pattern for Progress.